I'm welcoming here Professor Subbarao Kumbhapati, and it's an honor to introduce him. Professor Subbarao Kumbhapati is a professor of computer science at Arizona State University. Kumbhapati studies fundamental problems in planning and decision making, motivated in particularly by the challenges of human aware AI systems. He's a fellow of Association for the Advancement of Artificial Intelligence, American Association for the Advancement of Science, and Association of Computing Machinery, and was in NSF Young Investigator. He served as the president of the Association for the Advancement of Artificial Intelligence, a trustee of the International Joint Conference on Artificial Intelligence, the chair of AAAS Section T, Information, Communication and Computation, and a founding member of Partnership on AI. Kumapati's research, as well as his views on progress of societal impact of AI, have been featured in multiple national and international media outlets. He ca- and so we are really honored to have you here with us, sir. And I really welcome you. Let's start the talk and looking forward to listening to you.
Thank you. Can you hear me?
Yes, sir, you are audible.
Okay, great. Thank you. Thank you all. So I, as they said, I am Rao Kumbhapati. And so when I was told, when I got this mail saying that I should give a talk in Jodhpur, I was quite excited because the last time around I was in Jodhpur. I enjoyed, going around your very beautiful city. So I was packing my bags, and then I was told this was going to be on Zoom. So I am going to be enjoying your blue city on Zoom. I can't see you guys, but certainly, hopefully, at some point of time again, I'll get to go there. As you can see, the last time I was there, I was much younger than I am here right now. Anyway, so as they said, I basically am mostly interested in planning and decision making and human AI interaction. Before I get into that part, I also wanted to mention that I do a bunch of, like many people who've been working in AI, we've been actually scratching our heads at the pretty exponential progress in certain kinds of tasks. In particular, as I tell people, essentially AI systems used to be very good at explicit knowledge tasks. Now they suddenly became much better at tacit knowledge tasks, the ones that kids do first before they do explicit knowledge tasks. Things like writing, things like listening, things like speaking, these things that you can't actually teach a computer how to do it other than by giving examples. That's the stuff that AI systems have suddenly become very good at doing, and we are going through a pretty fertile period. So one of the interesting things about these tacit knowledge tasks doing extremely well these days is that now we tend to think everything is tacit knowledge, that there is really no place for explicit knowledge, which actually makes no sense because human civilization progressed because of explicit knowledge and codified knowledge being passed on. And so really we need the ability to handle both types of tasks. And so once, you might be interested in reading this kind of viewpoint on Polanyi's Revenge and AI's new romance with tacit knowledge. Also, the other interesting thing that we're going through in AI these days, which I guess as a neuroscience, a brain science community that most of you are, probably that's natural for you, but it's not at all natural for AI people, is that AI used to be an engineering discipline. Now we have sort of become an ersatz natural science, where we take these large-scale models that have been trained and trying to see what can they do other than the stuff that we trained them for. So that has been actually quite interesting. One of the things that you may have heard of is GPT and ChatGPT. And while they were supposedly trained for basically completion, sequence completion tasks by just completing, predicting the next token, they seem to be, quote unquote, exhibit several interesting emergent properties and that have taken people's imaginations quite significantly. One good thing that I can tell you, as I mentioned, I'm a planning guy. Planning continues to be a shibboleth. So if you give even simple planning tasks to these large language models, they have pretty bleak performance in terms of ability to get correct plans. That is the entire plan being correct, which should not be surprising to some extent, because essentially these sorts of systems are trying to capture the distribution, and they are not at all guaranteed to be correct at the instance level. So that's something in the background. I do want to, so as far as the talk is concerned, I'm going to, my research background is really on, most recently, I've been interested in explainable human AI interaction. Our setting sort of involves collaborative problem solving, where AI agents provide decision support to the humans in the loop. And whenever you're collaborating, you tend to expect explainable behavior from your collaborators. And if they become inexplicable, you expect explanations. And we want to have the AI systems provide that. So that's sort of our, research direction. So we have developed frameworks for both providing proactive explanations as well as FOIL-based explanations, which is basically when humans ask, why did you make this decision? The system should be able to provide why it made that decision. And we tend to look at them both in context of essentially embodied systems like robots, as well as software AI systems, such as basically planning support systems. And then finally, one of the other things, just before I go off of this talk, is that when you're talking about things like explanations, things like explainability, you really need to check whether your theories of it are actually relevant for actual humans in task performance. And so we tend to support our research, our findings with systematic human subject studies. So anybody who talks about explainability of AI systems and doesn't know what an IRB is, probably you should take their words with a pinch of salt. Okay. So given that research background, the talk overview that I'm going to try and do, it's very hard for me to actually figure out what your background is. As far as this audience, I've been an 11th hour add-on to this program, and the fact that I can't actually see anybody and I'm looking at the computer is not helping either. So I'm basically going to split the talk into 3 parts, and then sort of give you very high-level overview under both the technical parts, and then hope that those of you who wind up being interested in that will look up other resources that I can provide. So in the part 1, I'll look at why and how humans exchange explanations, and whether indeed AI systems have to actually provide explanations for what they're doing. And in part 2, using this background, I'll show you a significant amount of work that we have done in the last several years, which sort of takes the view that explanation and explainability involves reasoning about mental models. I'll talk about, and this is sort of done typically, specifically in sort of explicit knowledge, symbolic tasks. So they still shared vocabulary, but the explanations have to be still provided because the models might actually be differing from between the human and the AI systems. And then part 3, we get to the point where it is actually possible that the human and the vocabulary used by the humans and the internal representation of the AI systems are incompatible. And in particular, these are the case when systems are, you have large learned systems with what are basically called inscrutable representations. In those cases, I want to point out how the same kind of explanations can still be provided, with the heavy lifting of providing explanations being done by the machine rather than by the humans. Because, if at all AI systems were to become big in our society, I don't want my work to become more. My work should be less. And if in fact I need to collaborate with AI systems, the heavy lifting of making sense to me should be done by the systems rather than by myself. And so we talk about how even if the systems are actually not looking at symbolic representations internally, they need to provide a symbolic persona at the top level just to be able to provide the explanations that humans can understand. And it also goes the other way. When the humans are providing advice, they will still be providing it in a symbolic level, and the machines have to operationalize it in their internal representation. So those are the three pieces that I will try to do, hopefully like 15 minutes each kind of a scenario. So let me look at the part one. Why do humans actually ask explanations from each other? This is sort of imagine this as a Cliff Notes version of the literature in psychology and human factors about explanations between humans. That is when you and I are interacting with each other. Typically, we expect explanations when we are confused or surprised by the behavior. And notice that the confusion is orthogonal to correctness and optimality of the behavior. You may well be doing your task correctly, but if I didn't expect you to do it that way, I'm still going to be surprised and expect a explanation. How come, like for example, if your 2-year-old nephew starts telling you about astronomy and calculus, you would say, how exactly did you get this knowledge? So you would still be surprised, even if in fact they are correct. Explanations here help us to reconcile the expectations we have about the other human agents' behavior. The other time when we tend to give explanations to each other is when they want to teach the other person or to make sure that the decision that I just made is not a fluke. In fact, I know why I made this decision. One of my favorite exam questions for my students is giving a technical statement, asking them to say whether it's true or false, and provide a justification. True or false, anybody can toss a coin. It's a justification, which is the explanation of why you think this is the answer, tells me a lot about your understanding. And in fact, this sort of use of explanations essentially is localizing the fault, as it were, in the reasoning, if there is any. So finally, the need for the explanation is dependent on, as you can see from the first two bullets, right? The reason we need explanations is because we have an expectation about the other agent. And if that expectation winds up being different, that is, if our model of the other agent winds up being different from the reality, then we are surprised and we expect explanations. And when the models get reconciled, there will be less need for explanations in the subsequent interactions. And then a last point is, we also, as humans, basically romanticize wordless interactions between, agents working together. Basically, that happens when there is when you would stop expecting explanations or stop being surprised at other person's behavior if you trust them. So in general, trust between agents is connected to whether or not you expect explanations. The first time when you don't know somebody, you basically might expect explanations from them. But if you trust and you know that they know what they're doing, you stop asking for explanations. So that's something that we keep in mind. And we'll see that given this, with respect to that, the kind of machine learning, we'll talk about this in a minute, but, AI systems got interested in explanations too, but, the kind of settings that they look at tends to be a lot more impoverished than this. So that's something that I'll make on. How do humans exchange explanations? The primitive thing you can do is when somebody asks why, and if you don't have a language, if you don't have any shared vocabulary, you will point. You sort of, like mutely point to different parts of your surroundings to try and explain why you're doing this. This is what happens when kids don't have any vocabulary. For example, when kids are growing up, they're essentially doing mostly signing to points in the world, and those kinds of explanations are the tacit explanations. The problem with them is they're quite unwieldy and high bandwidth, and they almost don't work at all if you're asking an explanation as to why did you make this particular decision. Why did you, for example, take this flight as against this other flight? Because pointing there would have to point to your life story. And there is really nothing that you can concretely point to. And this becomes an important issue when you come to human AI interaction too. The other thing that we tend to think of, almost take for granted, is explanations are symbolic. Symbolic explanations in terms of shared vocabulary. This is sort of feasible for both spatial and spatiotemporal data, and it sort of also assumes that the humans share a vocabulary with respect to which they are exchanging the reasons for their decisions. So typically, pointing explanations are used either for tacit knowledge tasks, and especially they don't work for sequential decision tasks at all, as I said about, why did you take this flight kind of a thing. And even for tacit knowledge tasks, we tend to, over a period of time, develop symbolic vocabulary. For example, you talk about things like, I used pick and roll in basketball. I know that you guys care a lot more, and I used to care a lot more about cricket, and what the heck is LBW. And it's a complicated concept, which basically, apparently, the umpires can distinguish based on the space-time signal tubes as to whether or not the leg happened to be exactly in front of the wickets. So we do actually kind of wind up converting even the tacit knowledge information into symbolic things, and then use them for sharing explanations. And then symbolic explanations are not only compact, but they reduce cognitive load for the receiver. One of the biggest things in explanations is if somebody asks you, why did you do this? And you kind of go into a harangue that lasts 24 hours, they would never again ask you for explanations, because that's just too hard for them to figure out what it is that you're saying. And so in general, the cognitive load is going to be much higher if you're showing like videos of your life story, for example, whereas you want it to be to the point. This is something we take for granted. Now, do AI systems have to give explanations? We talked about why humans seem to be sharing explanations. Human AI systems have, traditionally have always had explanations, and they've become a lot more important nowadays when you have large-scale systems being used in all day-to-day scenarios. So one of the issues, basically, the systems can actually do internal or self-explanations within the system, such as the explanation is essentially the system trying to make sense of why a particular failure occurred in the search and using that to improve the search. This has been done, for example, in search scenarios, search strategies, for quite a long time in AI systems. But of late, we are a lot more interested in external explanations, and these external explanations can be to other AI systems, which is one possibility, but more interestingly, to other humans, because I think the humans essentially wind up being a different, in the end, essentially, machines can almost have a hive mind together, so they almost don't need explanations. Whereas for the humans, thankfully, unless this Elon Musk character, kind of puts stuff into my head, I would hope that you still have to talk to me rather than just sort of probe, intervene into my brain directly. So we are actually providing, the AI systems have to provide to-the-point explanations to the humans in the loop. Much of what went on in explainable AI in machine learning has been, as well as general AI, has been about explanations to humans in the loop, but it sometimes gets confused with other types of explanations, as I will point out. For example, there are words like interpretability and certificates of correctness, which oftentimes are confused with explanations, and it's worthwhile remembering that. And it also should be mentioned that some people think explanations are not important. For example, people have said things like Facebook makes 25 million suggestions to people, and nobody asks it, why are you making this suggestion to me? My answer to that is you don't ask explanations for things that you don't care about. If, on the other hand, your doctor says you need this following costly surgery in the next 3 months, you definitely want to know, why do you think I need that surgery? Even if, in fact, you don't necessarily understand medicine, you still need an explanation for the decision. Okay, so that's something that we just expect, in general interaction. Um, the Yeah. So the use cases for human in the loop explanations include, this is another thing that I want you to understand because they tend to get confused. So sometimes explanations are used just to debug and flag and correct the system's behavior. Sometimes the explanations are done when the human is just an observer and it's a lay observer. Sometimes the human is an observer and expert observer, so they can understand actually how the task is supposed to be done, and so they can understand higher levels, more skilled explanations. So the usual thing is when a surgeon makes a diagnosis for you, they will explain their diagnosis to you in one way, and they'll explain the same diagnosis to their colleagues in a different way because the shared vocabularies are different. There's a bigger shared amount of knowledge that they can use. Okay. There can be collaborative tasks where, in fact, both AI system and the human are equal partners instead of humans being observers. And when you are a collaborator, the question is who is the teacher, who is the student becomes important. In fact, it winds up being that learning role and the human is providing advice, our human is providing explanation as to why a task should be done a particular way. And then finally, the use cases also differ on decision making. That's actually very, very important. As I said, for the sequential decision making, pointing explanations almost make no sense because I need to provide you a video of my life to actually point to why I did a particular decision. Whereas if you're asking me, here is a picture, why do you think it's a dog? I can sort of show some, regions and say, look, this is the regions that make it a dog. Even though really, between you and me, I have not seen any humans who ask me as for explanations on why I think a particular picture has a dog in it. They always ask me, why did I make a particular sequential decision? Okay, that winds up being more important. Also, the interactions are important. If you're just making one interaction between the human and the AI system versus if you have a longitudinal, that means you continue to interact. Because interestingly, when you continue to interact, the need for explanations sometimes goes away and sometimes might actually come back. One of my funny stories is when I came to US, I would be walking on the left side, and then people would in my department would also be walking on their right side. So we will bump into each other. So they decided that this bozo doesn't know that we are supposed to walk on the right. So they started walking on the left for me. At the same time, I learned and I started walking on the right for them. And we were again, bumping into each other. It's because the models that we have keep changing as we are learning from each other. And sometimes explanations become less important over a longitudinal scenario if you have trust in the other agent. The one last thing I want to mention with respect to this slide is explanations for this talk are with respect to being given to a specific human with a specific shared vocabulary, shared knowledge with you, okay? Interpretability, on the other hand, it's sort of used in conjunction along with explanations, but interpretability is really like, can humanity make sense of it as against a particular human make sense of it? For example, Rosetta Stone is interpretable for humanity, but if I show you Rosetta Stone, you can't make sense of it because you don't actually know how to make the conversion from cuneiform to the language there, okay? And then finally, there is certificates of correctness where a machine can make a 1 gigabyte certificate of optimality of the solution it found. This is certainly not an explanation for any humans. This is explanation by intimidation, because if I am given a 1 gigabyte explanation, I'll just throw it away. That's actually meant for my own AI system, if at all. So I'm mostly talking about explanations that are given to humans in the loop, okay? The requirements for explanations include comprehensibility. You want it to be understandable, with low cognitive load for the person getting the explanation. You should be able to easily exchange explanation, communicability, soundness, which is a nice thing to have. That is a guarantee from the other party that this explanation is really the reason for the decision. And a related guarantee is to stand behind the explanation. That means if that particular explanation is falsified, the decision will actually change. This is the kind of thing, if you're denied a loan and I give you an explanation as to why I denied you a loan, you change that path of your life, then so that you should be able to get the loan. If I still don't give you the loan, then you're saying this explanation is actually bogus, right? And finally, satisfaction with the explanation for the agent receiving the explanation becomes very important. And unfortunately, this is a huge slippery slope, because sweet little lies can get people satisfaction, whereas serious explanations sometimes make them, basically make them go glossy. And so one of the worries is, if all you want to do by explanation is just make people feel as if they understand what's going on without really providing soundness guarantees, which AI systems can do, then you are in pretty worrisome situation. My big worry is what happens if ChatGPT starts providing explanations to satisfy the GDPR requirements that, all decisions should be understandable to the humans. People basically, they kind of this plausible explanation, but that's not at all the reason the decision was made. So, given that actually in the AI, scenarios, explainability and explanations have been studied in very different settings. So that sort of caused kind of tribes. One is explainable classification, which is sort of the machine learning with respect to why is this a dog? Why is this particular X-ray showing that the patient has this particular disease as against a different disease? And then explainable behavior in the context of human-robot interaction, that is human embodied robot interaction. And then also explainable behavior in the context of planning, decision-making, sequential support, where the other agent is essentially a computer agent. It's not necessarily embodied. Okay, so these are different people working on explanations, and so they tend to work on different kinds of techniques. So actually the picture shows the top one is more from the examples from the XAI, from the ML community. The middle is XAI with human-robot interaction, and the bottom one is explainable AI with respect to a computer-supported decision-making scenario. Okay, so that's the first part that I wanted to give you a basic background that we kind of can share about when do people provide explanations to each other, and why do machines have to provide explanations to each other, to humans in particular. And then the part 2 and 3 is more of my work, which is the part 2 I want to talk about how we can, in the context of scenarios where both the humans model and the machines model can be viewed as symbolic models, how would you develop explanations? And then part 3, I'll talk about what happens if the machine's model is not symbolic. It has to convert its explanations into symbolic fashion. Okay, so in the case of part 1, which is several recent years worth of work in our group, so what does it take for an AI agent to show explainable behavior in the context of human agents? It turns out essentially it's managing mental models. I'm assuming several of you know the Salian test, which sort of tells you that basically you need to realize not just what you believe about the world, but what the other person believes about the world and about you. And that's how you actually provide explanations. And if you don't have that, explanations don't necessarily make any sense. They become soliloquy. You're just talking to yourself. Teachers who talk to the blackboard and to themselves don't necessarily make sense to students because they don't have a reasonable model of what the students are, where the students are coming from. So the way we do this, I'll give you a quick overview of this is I work from sequential decision making planning tasks. Right now we are looking at a symbolic task, and so symbolic description of the task is available. So there's the initial state, goals, actions, and there's an observation model, and there's a plan that you're generating. This is what you're trying to do. So if you have, it turns out that much of what I'm going to be discussing in the next 15 or so minutes on this second part is being discussed with respect to the symbolic, what I call planning domain description language models, but can be used for other types of sequential decision-making models, such as MDPs and so on, if you are familiar with that. And so, if you are a single agent, if you, the AI system now, are a single agent, then essentially it would be called like a single agent planning or classical planning, where you have a model of the world, MR, which is the robot's model of the world, and it's going to use it to basically reach, develop plans of action to reach certain desirable goals. Okay. When the human is entering into the loop, suddenly, essentially, human is entering into the loop, the robot needs to take into account the fact that the human has possibly a different model of the task, including the kind of goals that they have, that is M of H. So instead of MR, just of MR, you also have MH to take into consideration. And when the robot is actually looking at MH, that would be involving essentially helping the robot anticipate the human behavior in order to assist and at least not run into the humans. So for example, much of what happens when you have a Roomba robot trying to turn away when it bumps into you, for example, that sort of a thing are essentially intention recognitions of the humans in the loop, as well as intention projections. The robot sort of telling you which direction it's going so that you will get out of its way too. So that's like the second level model, that is MR, not only MR, which is the robot's model, but M of H, which is the human's model of the task. The interesting thing that happens is the moment humans are in the loop, they will always anthropomorphize the other agent. We anthropomorphize stones and ascribe qualities, mental qualities to it. We're certainly going to ascribe mental qualities to AI systems, and so the humans will wind up having MRH, which is their expectation of the robot's model. Okay, and this winds up being the most important thing, because this is the one they're going to use to interpret what is happening, what the robot is doing. And if the robot behavior is consistent with MRH, the humans are happy. If it's not consistent, they are surprised because they expect the robot to have worked this way and it's working a different way. So MRH allows the agent to anticipate humans' expectations, not just humans' behavior, but humans' expectations on it, and then allows that to either conform to those expectations, which is what I would call explicable behavior, or if you cannot be explicable, then do whatever behavior you want, but then provide an explanation in terms of these expectations. That means you try to get MRH closer to MR. That means the human's model of you, you're trying to get it closer to your actual model of the world. When I'm saying you in all these cases, you, the AI agent, that is the robot or the AI system. Okay, it turns out MHR and MRH are expectations on the models, and they don't actually have to be executable. They're sort of helping the robot as well as the human, but mostly we'll talk about the robot, to have an understanding of what the humans are expecting so that it can either confirm or provide explanations. So model differences with the humans in the loop, that is the difference between MRH and MR, can lead to inexplicable plans. That means the humans expected the robot to provide a particular kind of behavior. I'll show you an example in a minute. And then in that case, the robot has two options, because the humans are surprised that they did not see the behavior that they expected the robot to show. One is explicable planning, which is sacrifice optimality and forget about having a plan that is optimal in your model, MR, find a plan that is close to optimal in MRH. When it's a plan that is optimal in MRH, it winds up actually being possibly very costly for you, the robot. And that's the price you are paying just so that people are not surprised. And the other is do what is easy for you to do, but then resolve the perceived suboptimality by revealing the actual model differences between MRH and MR, so that hopefully humans will change their expectations of the robot. So here is a more concrete example. Imagine you have a robot in a kind of in a room. It's sort of think of this as a toy search and rescue scenario. There is when they started, the human and the robot both have the same map of the environment, that particular area. And then as the robot is going around, it might find rubble on the, on the ground, or there might be obstacles on the ground that the human is not yet aware of. So the human expects the robot behavior with respect to the model that they started with. So MRH would be the original map, but MR, which is the robot's map, is actually changing because it's getting new information as it is going in the scenario. So in this particular case, what happens is it should be, this video should be working. So here the robot is, according to the map, given the goal it's going, it turns out that this particular direction is the path that it's supposed to take, because that would have been the optimal path. So the humans expect it to have gone through that particular path, but it turned out that I put a fake obstacle there. So what happens in this case then is that the robot decides to actually remove the obstacle and then go through that path. When it did that, it actually did more inoptimal behavior for itself because it took time to actually make that path possible. Sometimes, that could very well be very costly. In general, behaving in ways that people expect you to behave can be quite costly to you, the agent. So this is something that, but if you do that, then you provide explicability, so the humans are no longer surprised. To provide this kind of explicability, the machine is making its policy in such a way that it now not only is trying to optimize the cost with respect to its model, which is cost of the pie with respect to MR, it's also trying to minimize the distance between the plan it is coming with and the plan the human would have expected given the MRH. And so try to do something closer to what the humans are expecting. And if you do that, then essentially you can provide explicability. There are ways of doing that. The other aspect is not to show explicability, but just do what is easy for you, the robot, and provide an explanation. And in our sense of the word, explanation essentially means you are changing the model differences. You're reducing the differences between MRH and MR so that the humans will have more accurate expectations of you. So that after this explanation, your behavior should make sense to them. So what would be involved in doing this is essentially changing MRH by telling the human, here is this epsilon, here are some additional preconditions for some of the actions that you didn't seem to be aware of, and here is this additional effects that the actions have that you didn't seem to be aware of. And if you do that, you will understand why I'm behaving the way I'm behaving. So in the continuation of that example, the robot essentially is now yelling at the top of its voice saying, the path from P7 to P5 is not clear, and that should be registered by the human. Once they register that, then they will realize that the next best path is the one it's taking, and so the behavior will become explicable. So after the explanation, the behavior becomes explicable. In general, generating these kinds of explanations involves a meta search in the space of models. In our case, the action models with preconditions and effects. And it turns out that the way you do this search can lead to different kinds of explanations. It's worth kind of pointing out that there is a degenerate explanation. In general, the robot can always have said, let me tell you the entire MR, just change MRH to my entire model of the world. And if it does that, then the MRH will become MR and there would never be any worry. But the problem typically is asking, when somebody asks you, why did you do this? Saying, look, here is my brain, take it, put it on your head, you will understand why I did what I did, is a trivial way of explaining your behavior. But that's not a particularly smart way to explain. It's extremely non-compact explanation. So you want to provide the minimum number of changes to the model that the human has to make such that they can understand your behavior. And it turns out that the way this search is done can lead to different kinds of explanations with different interesting theoretical properties. There are ways in which the human can learn this model of the agent can learn the model of this human. In the example that I said, they basically started with an initial model, and then so you keep track of the drift. Sometimes the robot might know that there is an uncertainty about the human's model. It's one of 3 or 4 different models. You can then provide explanation that makes sense to all the expected models. In the end, you may have to learn the MRH of humans. Typically, the interesting part about that is it cannot be learned just from the human's behavior. It has to be learned from humans' reactions to your behavior, because MRH is really about humans' expectations on the robot rather than their own view of the task model. And that actually makes the learning more trickier. And of course, when there are vocabulary differences, even if there are vocabulary differences, we can learn the expectations directly rather than actually generate a model, like an MRH as an action model directly. And there are ways of doing this with model-free explicability and model-free explanation, where you directly learn the human expectations from prior training. So those are possible. So we also do human subject studies to see whether or not the kinds of explanations we are generating are making sense. And we publish in, for example, human-robot interaction kinds of places where we show that these kinds of explanations that we compute actually improve the collaboration between humans working with machines. And setting up these experiments is a pretty tricky thing, because in general, getting human subject studies done correctly, in that particular case, we had to gamify the system gamify the setup such that the humans have a stake in actually doing well in the collaborative tasks, so that they're giving feedback that is actually relevant to whether or not the explanation is useful. And I'll skip over this, given that we don't have too much time. That basically, when the human and machine are working together, essentially they go through this cycle of either the robot tries to follow the human's model by being explicable, or it tries to change the human's model by providing explanation. And then this cycle continues, over a period of time if you're doing longitudinal interactions. Now, it turns out that, remember, I showed this picture earlier. If I had time, I could have shown you how the way we are computing explanations actually corresponds to how the humans are giving explanations to each other. In particular, the properties that I was looking at are actually satisfied by the kind of explanations that we are computing, as well as the way we are computing them. So that's the stuff in the yellow. It turns out that you can extend this general idea in multiple directions to provide customized explanations to different humans, with different shared vocabulary, shared border, different MRHs. You will provide explanations that make sense to each of them separately. You can provide explanations proactively as soon as you know that your behavior will be surprising to them, or wait for them to ask you questions. You can handle model reconciliation in non-PDDL settings, that is, things that are like more in MDP sorts of scenarios. And then, most interestingly, the one piece that I want to explain to you is, in general, mental modeling opens up a Pandora's box. Lying is possible when you can realize that other people's models of the world are different from your models of the world. And so, in general, you can actually use this to both cooperation, which is what I've been talking about, but you can also use it for obfuscation. If you want the robot to deceive a human, you can actually make that happen too. Lying with mental models are possible. We actually did some work to show whether or not, first of all, it's possible to do this, and secondly, how even if you're doing white lies, whether people are okay with being told white lies by AI systems. You do realize that you are completely okay with being told white lies by other people. If anybody asks you how do they look, you have to tell them, yes, you look great, unless you know them extremely well, when you can tell them the brutal truth that they're not looking that great. But normally, entire fabric of society depends on white lies. Do you want your AI systems to tell you white lies to nudge you to do something reasonable, for example? That's something that we can talk about. One last thing here is engendering the trust to improve performance is something that we can do. In fact, there's a paper that's coming out in HRI this year, which basically looks at the fact that in the beginning, the humans might expect the robot to be explicable. But as the robot becomes explicable, that means it's conforming to their explanations, they might stop monitoring it because they sort of increase their trust in it. At that point, if the human is not monitoring what the robot is doing, the robot actually can do things that are more optimal without having to worry about the need for explanations. That improves the system's performance, the joint system's performance. So in a longitudinal scenario, you can set it up such that there's a meta problem that the machine can solve as to how long would I be explicable to you so that I can start doing what I want to do because you will stop monitoring me. That's a very interesting way of leveraging longitudinally engendered trust. This is something that is possible in this kind of a models. Up to this part, we have written this as a book and it's available, and there's a bunch of pieces that I really couldn't go into because of the time limitations. But that sort of tells you the general idea about this sort of providing explanations. And the last part, which is hopefully another 10, 15 minutes maximum, is to give you a sense of very recent work on supporting explainable behavior even without a shared vocabulary, where the machines don't have symbolic vocabulary at all. They are essentially thinking in pixel space. They are thinking in signal space. And they're making the actions are common. They're making the decisions, and the human asks, why did you make this decision? And the question is, how do the explanation get provided? And as basically, when there is a vocabulary mismatch, the point is pointing explanations of the kind that XAI, machine learning, explainable machine learning people have been looking at, such as kind of doing things like saliency regions. They're completely useless. As I said, you can't talk about saliency region over a sequential behavior because that becomes sort of a video of your life, a space-time signal tube, as it were. And as I mentioned earlier in the beginning part of the talk, pointing explanations are actually hard to comprehend. Even if you somehow can make this video, cave people didn't have videos. There's no way to kind of sign all the things that happened in their past that made them make these decisions. So hopefully, maybe that's one of the reasons why we had to almost invent symbolic language, because that's a way of compactly describing the reasons without having to point to the space-time signal tubes. Now, what we are doing is the AI systems essentially have to provide this kind of a support. We want, irrespective of the system's internal reasoning, it should have a symbolic interface layer that it generates. Not the humans generate, but it generates, and it uses that to exchange explanations with humans. So that AI systems, and since I said sort of internal reasoning and symbols, you may have heard a lot, several of you may have heard of this whole neurosymbolic AI, which is whether or not, AI systems should actually have symbolic components to it. It turns out that there is like two different ways of looking at it. One is internal symbolic reasoning. There are people arguing that eventually AI systems need symbolic reasoning in addition to whatever else they are doing currently to be able to reach human level intelligence. I don't have a position on that. I'm not going to take a position on that at all. The position that I'm going to take in this talk is symbolic communication interface. Irrespective of the way you are reasoning about the task, the AI system are reasoning about the task. When I ask you why you did something, you can't throw some bits at me. You can't throw some binary gobbledygook at me. You have to provide explanations that make sense in terms of the shared vocabulary that you and I have. Okay, that is something that, this is what we are calling essentially external symbolic external neurosymbolic interface that every system has to provide. So in the use case, essentially is that irrespective of the way the system is actually doing the reasoning, it provides an interface through which it can provide explanations as well as take advice. In terms of explanations, there is a paper in iClear last year, which sort of gives you an example of how it can be done. So you have a system which was sort of solving Montezuma's Revenge, which is essentially a non-symbolic RAM state representation is what it is using, this deep reinforcement learning system. The humans ask, why do you make a decision in a symbolic way. For example, why did you take this action? And the reasons for that system has to provide have to be in terms of actions and preconditions and effects that humans can understand, even if in fact that's not the way it actually did its internal reasoning. So what we do at that time is that the details are actually in the paper, but to those of you who are technically inclined and interested in looking at it, the idea is that you generate around the decision which is being challenged by the human, saying, why did you make this particular action at this place? You're generating a sort of a local symbolic explanation. You, the AI system, is generating a local symbolic explanation by essentially learning on the spot at that point, online learning, and then generating that local symbolic model, and with respect to which then you can do the previous parts that we discussed, which is how to compute explanations once you have a symbolic MRH. Okay, and it turns out that this way of doing, we can also compute like the confidence level of the explanation, and that can be used to also say whether or not we have enough shared vocabulary, or whether in fact we have to increase the shared vocabulary, whether the machine needs more concepts that need to be grounded so that it can provide better reasons for its explanations. You can use the same kind of ideas for accepting advice. The humans should be allowed to provide their preferences and their advice in symbolic terms, rather than being shown two trajectories and saying which trajectory do you like, because that's just a very costly way for humans to actually provide the feedback. And so giving this kind of taking this kind of an advice can also be improved quite significantly by the system being proactive in converting the symbolic advice into the form that it needs. So in a New RIP Spotlight paper last year, we basically looked at this question of if the human is providing suggestions on what actions should be done at what point giving an advice to the underlying reinforcement learning agent, it can then, for example, and their advice would be, for example, you should be doing brake action because there is a stop sign. And then it needs to convert that into the internal representation it's using, which is the pixel-based representations. So it basically can convert the stop sign into a region. And then not only that, it can keep that region and blur the rest of the regions in multiple different ways to increase the data. The same feedback, one single feedback that the human gave can be converted into many more feedbacks, which can then improve the learning performance for the RL system. So this is basically, again, the machine doing the heavy lifting of converting, operationalizing the human's advice. Okay. The last thing which I want to mention today is, this is true even for things like essentially tacit behavior. So imagine you're trying to you have this, much of the preference-based learning work in AI suddenly got interested in tacit tasks such as walking. And so the question is, if you want to tell the system walk fast or walk slow, you should be able to say that rather than basically have a very inefficient way of giving your feedback where you're shown pairs of walking trajectories and you try to say this one is better than this one. And that takes like forever to get your idea across that you want to walk fast or you want to... So basically you're providing symbolic information that sort of relative attributes over these continuous trajectories, such as how you walk, etc. And it turns out that the interesting question is, just as in the previous one, we had to ground the meanings of the terms. The machine has to ground the meanings of the terms for the shared vocabulary. Here it needs to ground the meanings of these relative attributes. That is, what does faster mean? What does slower mean? What does softer mean? Walk softly, for example. What does softer mean? It needs to learn that in a priori set, in the previous early setting, and then use that to essentially operationalize the advice that the humans are giving. And that's actually a paper that's just coming out in iClair, this year, that tells you how this shared vocabulary can also include essentially relative attributes, and then that improves the ability, it sort of makes the the explanations as well as advice taking a lot more compact for the humans in the loop. Okay. There are other things that we can do in that context. I don't have time right now. One last thing I want to mention is, in general, even when you are trying to, if you play dumb charades, for example, where you're miming some movie name and other people are trying to guess what the movie name is, their guessing involves trying to make sense of your miming in terms of symbolic concepts that you both share. So it turns out that shared symbolic vocabulary and the grounded shared symbolic vocabulary winds up being helpful even in reducing that ambiguity of the human demonstrations, if in fact humans are teaching the robot skills by demonstrations. That's something that we have shown. So much of this stuff, this kind of a direction of research was discussed in a Blue Sky paper that we have this year and last year, 2022, in AAAI, as symbols as a lingua franca, which also talks about some of the open problems, parts of which we have looked at, but parts remain, such as collecting the initial concept set, grounding the concept set, and vocabulary expansion. And as I said, in the case of vocabulary expansion, it can actually be two different ways. If the confidence in the explanation that the machine translated is too low, it knows that there is not enough vocabulary to convert its explanation into symbolic terms. At that point, either it expects a new additional terms from the human for which it needs to learn the grounding, or it and the human together have to come up with new terms that make sense. In particular, for example, in that AlphaGo's infamous 37th move, people find that move very surprising, the human Go players. And that's because they don't have a compact symbolic reason as to when that move should be made again. And in fact, in those kinds of cases, you would have to almost develop new vocabulary in a human and the AI system together have to develop new vocabulary so that that explanation process can still be compactly communicated. So in summary, the part 0, I try to tell you about why humans exchange explanations and why machines need to do it in different settings. And then part 1, I try to tell you how that sort of explanation computation can be done in symbolic models. And in the part 3, I try to tell you how that can also be done when, in fact, the machines are allowed to do whatever the heck representations they have learned, but they still need to talk to us in representations that make sense to us in terms of the shared symbolic vocabulary. So I'll stop there. I have no idea what's going on out there. So if there are any questions, I will be able to answer. Thank you.
Thank you, Professor. I hope I'm audible to you.
Yes.
All right. So yes, we have... So, Professor, if you can, if you stop sharing the screen,
okay,
we can start the Q&A now. Yeah, thank you. And the videography team is working on. There is some small glitch at our end for connecting the camera, so we are working on that. Meanwhile, if we can take up the questions, because I see at least it was very exciting talk for me. So we'll be doing that. Meanwhile, we'll try to work on with audio. So the session is open for Q&A, and if there are questions, please raise your hand. The mic will come to you.
Well, thank you for that. You can't see me because they are trying to work on a system so that you can see us. So you just have to see this disembodied voice right now. So I'm Neeraj Jain. We communicated briefly by email. This is very exciting talk and very important. I think I was thinking through particularly the first part, that even human to human interaction, there are a lot of lessons there, which actually can be used, not just AI and human. And a lot depends on the trust. But you brought out a point. You asked Chat GPT for an explanation, and it gives an explanation that, according to Chat GPT, human is expecting. Now,
No.
there is
I was actually saying ChatGPT has no understanding of the world. It has the understanding of what's the most likely next token. My big worry is if you generate explanations, if you ask ChatGPT to explain, it will provide an explanation which has nothing to do with the decisions that were actually made by the system. So, but they might look plausible to the humans, and they might just go with that, saying, yeah, that looks like a reasonable, reason. And then, but that sort of defeats the purpose. Of course, we also do this. When people ask, why did you do this? We might lie and provide an explanation that has nothing to do with the real reason why we made that decision. But I don't really want to encourage development of AI systems that are, such that one system makes the decisions and another ChatGPT just sort of says something random. And since we are basically quite gullible with respect to, we kind of can, assume that if it's a good farm, it's in the right farm, must be like a reasonable explanation. And then that would be a big worry. That's a worry that I had. ChatGPT is not my system at all. I'm just saying should not be using, there is that worry about having explanations being generated that are clearly not connected to anything that the system did. Okay.
Right. So, absolutely. So, the issue that comes here is when we are talking of explainable AI, we need to be able to query as human as to the processes that are going on, which are leading to a particular decision.
Mm-hmm.
That will be an ideal explanation for any decision, which is essentially looking into how the network has developed inside the AI.
No. Actually, I'm sorry, but you continue, but I will disagree.
Yeah. So let me just finish. So now that's not really an ideal path the way I see it, for the development of AI, because that's not what we want, where we actually can analyze in detail what is happening at every node of the network. So explanation, that means, has to come from within the AI agent.
Yes.
How do you actually guard against the kind of things like you said, small lies?
Yeah, you can't. First of all,
yeah. So that's really what my query is. That this is a conflict, basically.
No, but all bets are off right now with the way AI is developing. Okay, so there's basically our gullibility is very much in display, and we basically have always confused form with content. And we hope that anything that is actually true will also be written in good English. ChatGPT will only write good English. It can't write bad English, unfortunately. And so we assume everything it says is, you could potentially do that. And that is going to be a huge issue. I can always give guarantees that my system is not doing it, but I can't give guarantees that some system from, that you have bought from, that you're interacting with no provenance about how that was designed is guaranteed not to lie to you at all. And then the other thing I do want to push back pretty strongly is that it's not a failure that we don't get to look at what's going on at every node in the network. It's not a failure to me that I don't know what's going on in your brain. It's basically I will use your explanation of why you did what you did without having to lobotomize you, which I'm told is not allowed, but I also don't want to do it. It's very messy. It's going to be too complex a way to interact with you. It should be the case that if I ask you, why did you do this? It's incumbent on you to provide an explanation, which I can either trust or ask more questions. That's exactly what we should do with AI systems. This confusion of debugging the internals of a learned system with that system explaining itself to us is something that I was hoping we could get out of. That's the reason I actually put that first part, because debugging a learned system is not making it explainable. explainability is something that you provide. When I ask you, why do you do this? You provide the explanation at that point of time. I don't want to actually take the time to look at what's going on at your neurons level, unless I'm doing some kind of a crazy polygraph test on you or something. And I'm happy that in the world that I live in, we are not always stuck to polygraphs, right? Which itself is a pseudo science, as I understand. But, thankfully we don't have to do that.
Yeah, okay, thank you. I mean, that's the clarification that I was seeking from you. Thank you very much.
Are there any other questions? Yes, there is.
Thank you, Professor, for the talk. You discussed for the answer to the previous question. How do we break through this cycle of having a model to learn a particular operation and then at the same time have models to generate explanations for them? Like, how different will their learning mechanisms be?
Okay, that's actually one of the other things. I mean, this is, thank you for the question. I actually think that learning to explain is the worst thing you would want AI systems to do, because then they're learning what will make you happy rather than what they actually did. Children learn to explain what you want to hear for whatever they did, and because they're smart, they actually know whatever they do, they'll tell you a nice lie that you will believe that's plausible. I don't want the AI system to do that. I'm in fact not learning how to explain. If you notice, if you kind of go through the talk that I went through, the explanation is actually providing a summary of my decision making. Okay, I'm not learning. Okay, I'm just trying to. The only learning is converting it into shared vocabulary that we have. So, and in the first part, essentially, explanation is a sort of a model differences being communicated, right? That's not what would make you happy. If I learn what would make you happy, that would be the worst form of explainable AI, because the systems will be doing whatever the heck they want, but we will be none the wiser because we are being told what we want to hear. Okay, our children already do that to us, and we certainly don't want superhuman AI systems to do that to us. Okay, so I think I'm not learning how to explain. I'm explaining my decision process to you in a compact way. And that was the whole point of both the pieces, that's part 2 and 3. Yeah, go ahead.
So then how can we not try to debug, like how can we explain without debugging those models, right?
When you say we, what are you talking about? Are you the AI agent or are you the human agent?
The AI agent, without querying the AI agent about its learning mechanism or what did it see for a particular prediction, how can we translate it to a common model?
We will ask the AI system, why did you make this decision as against this other decision? And then it will provide an explanation saying, well, that other decision has this additional precondition because of which you can't do it. That's the kind of examples that happen in that examples that I'm showing in the Montezuma's Revenge and so on. That's what you are doing. You don't ask the system, did you use Adam for optimization of your network? Did you use transformer architecture? That's none of our business. It's basically you want its explanation of why it made its decision in terms of the model that makes sense to us. And that basically is, I think that's again, ask yourself, if you play human agent and your friend plays AI agent, ask yourself, what would you do to your friend? And you don't want to do any more to the AI system than to your friend. You don't get into lobotomizing your friend. Even if it was legal, it's messy. It wastes your time, right? And you still basically get explanations from humans. You want, if the friend now becomes an AI agent, it should still be able to provide that same sort of an interaction. That should be the goal. That should be the holy grail.
Yeah. Thank you. Thank you, Dr.
Okay, probably we can have last question and then we'll move to our next talk. Our speaker is already with us. So we have one more question.
Hi. Hi, my name is SP Arun. I'm a vision neuroscientist.
Okay.
So I've been listening to your talk, wondering about how thinking from the point of view of visual perception. And so my question is really, do you think that symbols can arise, that a system would, for example, maybe using, for example, in vision, we might be using all kinds of different features for our, perception tasks. But then when you're, is it possible that certain kinds of very commonly used operations might emerge as symbols? And you haven't really talked about how symbols might emerge.
It's again, please understand that I put 3 talks that I would use and 1.5 hours each for in one talk, because I have no idea what will make sense. So these questions are very helpful. It's a very good question. I would like to clarify that I'm not talking about symbols internally arising at all. That would be what the internal symbolic reasoning people will say. That is, the machine somehow will do symbols as abstractions, but then if the symbols develop that way, first of all, it's not even clear that those symbols would make any sense to us. I mean, there's this beautiful quote by Wittgenstein that even if a lion were to speak, we won't understand, because there's the point is whether the symbols that would emerge would make sense to the human or not. I'm not at all talking about that. I'm mostly, when I talk about symbols, these symbols already make sense to us. So if you take something like, since you're from vision, you take something like scene graph, right? Scene graph essentially takes a picture and is basically providing like a sort of a logical description in terms of connectivity, etc. What are those terms? Those terms are not made by the machine. They are terms that make sense to us. So a scene graph is a representation, a logical representation of the scene in terms of concepts that the humans already understand. And so if
those are linguistic terms, and it's not clear that the visual system is using those linguistic terms.
No, but that's okay. My point is that when I'm asking explanations, I only want explanations in terms that I understand. Unless you are saying that you and I have visual symbol terms, unlike linguistic symbol terms, we don't have anything that we're disagreeing on. Because a different question that could be asked is, would symbols arise in a system that is starting from signals and is reaching human level intelligence with no humans inside? Okay, that's a very different thing. In fact, that's the other very important thing. It's easier to be intelligent on Mars than to be intelligent in the presence of you and me. It's great, but I'm hoping that I want AI which actually doesn't push us onto Mars or it goes onto Mars, right? Either which way, that would be sad. It needs to be with us, and when it is with us, then essentially the things, even if it develops symbolic vocabulary internally, it still needs to convert it into explanations that make sense to us. So that's why I'm completely ignoring the question of whether the internal reasoning is symbolic or not. All I'm saying is you need to have a symbolic persona. And you and I do this already. I mean, even as we are speaking, we are talking in linguistic terms. Do I have any clue as to whether you are thinking in English or Hindi or at all in any language? No idea, right? But that didn't stop us from communicating. And that's all I want with, if I can have what I have with you, with AI systems, I'm happy, man. And I don't want to do any more or any less. That's the point.
Thank you.
Yeah. Thank you.
That was very interesting. And if I may say so, being a psychologist, it sounds to me that we are talking about having a shared theory of mind, being able to at least communicate to each other.
Mental models are indeed, yes, indeed, yeah.
Yes, thank you so much, Professor. It was indeed a very, very interesting talk. And I see people here are having a lot of thoughts here. We need to move to the next speaker now, the Jinjin Zhang, who's already with us.
If I might just say one thing, if I don't mind, if people have any questions, please feel free to send them to me. I'm also on Twitter at Rao2Z, and I'm happy to answer. But otherwise, thank you for having me.
Thank you so much, sir. Yes, and we will share the details, and others already have it. So thank you so much. We'll do that. And for that,